Okay, so hello everyone, this is Akshay here. Let us continue with today's GFG POTD suite. Today's question name is Palindrome linked playlist. And so let's read the question and we can see how we can solve it. Okay, so let us highlight the important parts of this question, or let's say the important constraints of this question. So we've been given a singly linked list of integers. The task is to check the given list is palindrome or not, right? So what does a palindrome means? That the last character or the first character be same and similarly so on and so forth for the subsequent characters, right? Let's say it is ABC, then the other half should be the exact replica of the first half, just it should be the reversal of it, right? So in this case the first and last character will match, and the second last will match, and similarly third and third last will match, right? In the case of odd characters, let's say ABA, the first and last character matches and the second one is the middle element. In the odd case, remain same for both of the halves, you can say, right? Okay. So method one for this approach, right? If this would have been a string, right? So we'd have maintained two pointers, let's say start and end, right? And we'd have just said that while start is less than equals to end, we just have matched the characters, right? That if st of, or if the string of, if string of st, if it is not equals to string of end, right? And there would have we would have said just return false, right? So what privilege we have while we were traversing in the string, that we can traverse from both the ends towards the center. But in a singly linked list, we do not have that privilege, right? We can only traverse in one single direction, that is towards from life from left to right, right? So as a brute force technique, how we can do this is that we can use a stack here, or in Java, there is one thing array deck, right? So array deck is nothing but it supports both the operations. That is, it can take push and pop from either sides, from front and last as well. So it is safer to use array deck if you're coding in Java, right? And it handles the operation for stack and queue as well. Okay, so what I'm saying is that for this array deck, we will traverse in the given list. So we have list as 1, 2, 1, 1, 2, and 1, right? And we will push all the elements into the stack, right? So what will happen? This one would get pushed here, then similarly second element, third element, and then 1, 2, and 1, right? This would be your stack elements, right? Now what I need that I need to compare my first with the last. Now this last element is the topmost element of our stack, is it? So what we can do here is, so the basically in the given list we can traverse from the left to right, and from the last element we need to compare, and the last elements and subsequent, the second last and third last, would be getting from our the topmost element of the stack, right? And at any point of time, if our topmost element of the stack do not matches with the current element in the traversal of our linked list, we will just say return false, that it is not a palindrome. I hope you got this technique. And what is the time and space constraint on this in this approach? So it would be O of n, because we are traversing the linked list and putting elements in the stack. And since we are putting elements, all the integer values of the given linked list in the stacks, it would be O of n, right? Now let's pause this video here and try to code this approach by yourself. ठीक है, so हम इसको full screen करेंगे यार, uh, and we're gonna start ahead the code. So as I said, we will use array deck here, and let me zoom in a bit. Array deck, I'm gonna use the integer type because we need to push the integer values, right? And we have a new array deck. Okay, so need to push all the data of linked list into stack. So we gonna traverse in the linked list, and for that we'll use a temp pointer, or let's say a current pointer. That node current is pointing to head, and since we are going to the last, right, I will say my last node, my current as uh, my current should not be equals to null. If that is the case, then we'll keep on traversing it using the next. That is current is equals to current dot next, right? and we have to push the data values. The node consists of two things: the data, the integer data value, and the node, the next pointer to the subsequent node, right? So we will push st dot push the current dot data, right? Now we have all the data here in the stack. Now again we will assign our head or our current to the head, and we'll again traverse in the given list. I'll just say, let me copy the above things. Okay, and we're gonna edit this line, and we're gonna say that if my st dot pop, right, is not equals to current dot data, then in that case I will just say return false. If that is not the case, we'll keep on checking for all the subsequent nodes, and at the last we will say return true. That is outside the while loop. Okay, so let us try this solution. Let us compile and run this solution. Once it is compiled successfully, again the question will go back to you that will this code be submitted, right? If you see the constraint of this code, now our solution gets submitted or not totally depends on the constraint, that is the n points to which high number. So it is, as of now it is pointing to 10 power 5, and if we see our solution is in O of n, if I try to write it or map it in the number of in the numeric terms, so we are using 10 power 5 iterations at max, right, which is less than 10 power 8 iteration. And that is why even this is our method 1 or brute force or whatever you can say for this technique. We will not get a TLE for this approach. This code will successfully get submitted, right? What is 10 power 8 approach and what is TLE? How does it come in play? How do we decide, or how do we read the constraint? And while reading the constraint, how do we get to the algorithms, right? So there are two videos on our channel. The first one is the trick the TLE, right? You must watch this video. You can search this term with my name, that is Akshay. Second is, I was invited as a speaker at SRM University for the time complexity Q&A, right? So there I emphasize this 10 power 8 logic because in colleges or universities, this logic is not taught by professors, or this topic is left untouched, right? So that is the reason I specifically emphasis on this 10 power 8 logic, 10 power 8 constraint. So you must watch this video because here you are not able to ask doubts to me, but in this video the students there asked had the generic doubts and we cleared them. We specifically showed them the power of constraint using the GFG platform and the lead code, right? Okay, so must watch that video. So now we have the answer, right? If we submit this solution, definitely will not get a TLE. So let's wait for that and let's move ahead with the second one. Great. So out of 9 attempts, so definitely I have solved this question in the past. That is during my placement season in 2021. Now let us look at the method 2 approach. I think you were able to see this submission. Okay, this. Let me submit it again and then we will move ahead. Great. As you can see, all the test cases has been passed. So let us move ahead with the next approach. So method 2. Uh, if you see in this question, they're saying that you should not use a recursive stack space as well, right? So मैंने हमेशा बोला है यार, if you're using a space, right, let's say you're using an array, then definitely you utilizes the space of, let's say if you're using an array of size n, right? But there is a high debate on this recursive space, right? So we also consider this recursive space as a space complexity. In many interviews I have seen on many uh, uh, in many interviews, yeah. So people neglect this recursive space and consider this as O of 1, right? Let's say we have order traversal of a binary tree, right? And we use a recursion there. So we say that the time complexity is O of n and space complexity O of height of tree. We cannot say space complexity is O of 1 because height of the tree is the recursive stack space which we are using to solve this in order traversal and for rest of the traversal as well. That is pre and post. But the level order is a BFS technique, and there you can say, but still also there we use a Q, so O of n is O of width of tree is there, right? Okay, so we are diverging. Let's come back to our method 2. So we have a strict rule that we cannot move in the bidirectional, right? We can only move from left to right. So we're gonna use some prerequisite. First one is reverse. And how do we get the middle of a linked list? in constant space, right? So must watch this video. How? So there are two videos on our channel uploaded already. That is a delete middle of the linked list. Definitely you will get the glimpse of how we find the middle in constant space using two pointers technique, and another is a reverse a linked list, right? And you will get this is a recursive approach, by the way. In this reversal linked list, we use an iterative approach, and that is the reason the space complexity is again O of 1 for both of the questions. That is to find the middle and reverse the linked list. Now, okay. So these are the videos linked. That would be present in my description as well. You must watch them before executing our method too, right? So the intuition behind is this. So let us take the first example. It is 1 2 1 1 2 1, right? So it is 1 2 1 1 2 and 1, right? So we'll get the middle of it. And how do we get the middle of it? Like we have, let's say, two cases. Let us assume we have a odd number of nodes, that is 1 2 1 2 1, right? So we appoint a slow and a fast pointer both at the head, and we move slow by just one pointer ahead and fast by two pointers ahead, right? So at the next step, slow will come here and and fast will come here. Similarly, at the next iteration, slow will come here and the fast will come here at the last, right? And if you see, when you are at the end of the list using your fast pointer, the slow will exactly point to your middle of the linked list, middle of linked list. Similarly, in the we can see in even case as well. So let's say 1 2 2 1, right? Here we can see slow and fast again pointing to head, and slow will move just by just one pointer ahead, and fast moves by two pointer ahead. So fast would be here. Again, slow would be here, and fast would be coming to null. So at the end of the linked list, right? So here you can see that while you were like, let's try to write this middle, finding the middle of the linked list as a pseudocode. If you see in the odd case, my fast is pointing to my last node. And if you see in the even case, my fast is pointing to null, right? So while traversing your slow by 1, that is slow is equals to slow dot next, and fast is equals to fast dot next. While doing this, what should be the while condition of your loop, right? What should be the condition for your while loop? You can clearly see that at first we can see the fast is pointing to my last element and points to null as well. So I need to check that fast should not equals to null, and fast dot next should also not equals to null. Then in this case we'll move these pointers ahead, and this slow will give you the middle of the linked list, right? Okay. So iska so the final intuition is that we'll get the middle of the list. We'll get to the middle of the list. Now this is the second half of the list we need to compare, right? This is the first half, this is the second half, right? But this first element should be equal to the second last. So we will reverse this second list. We will reverse the second list. So this is the first. Second is your first list would be again the first half. Your second list, we will reverse the second list. So what would be? It would be this is 1 to 1, right? So it would be again, if you reverse it, it would be again 1 to 1, but it is the reversal, right? So this one is mapping to this one, right? And this one is mapping to this one. And we will just check. We will iterate in both of the lists. If both of the lists should exist, while both of the lists should exist, we will just compare the nodes. And if the data matches, we will continue. And if at any point of time if data do not matches, we will return false, right? I hope you got this point. I hope you got this point, right? Okay, similarly in the even case, so it is 1 2 2 1. So this would be my first half, this would be my second half, and the reversal of it would be again 1 2 pointing to null, and my first half pointing to null. Again, we'll check at any point of time if the nodes data mismatches, we'll just say false, right? Okay. So this would be our entire approach as two-step process. Now, in the first half, you see that we pointed our, let's say this was slow pointer, right? The middle of the linked list. Just before the node, just before this node, I need to point this node to null, right? So we need to maintain, let's say, a pre-PTR slow pointer, right? And before assigning as slow to slow dot next, we need to say that pre-PTR slow is nothing but slow. So at the last, what we can say is that pre-PTR slow dot next is equals to null. So this will actually give me the first half of the list with the last pointer as null, right? I hope you got this point. Okay. So having said that, now we will call a node reverse function. So let's say we say node second head. right? And we'll call the reverse function with this uh, this middle pointer that is slow, right? And we'll just compare. We'll just compare. Now let us understand the reverse function as well. Let's understand the reverse function as well. So let's say you have a node 1, 2, and 3, right? And you need to find get the resultant as 3, 2, 1 and null, right? So this would be your head, right? So there are 4 pointers basically you need to maintain. This would be your current. This would be your next. There would be one previous pointer, right? Because one you can see it is pointing to null. So this is our previous, right? So with previous that will be pointing to null. So there is a 4-step process. So this is your first step. You write as next is equals to current dot next, right? As the second step, you point this current. This is your current, right? Current to head to previous. So second step is current dot next is equals to previous, and then previous dot next equals to head. Previous dot, not next. You'll just move the pointers ahead for the next iteration, right? So your previous would be head, and similarly your current would be next. Not head. Head we have appointed this first node as current, right? So previous equals to current, right? So let's say in the next iteration, what will happen? You will have this one, which will point to null. Now this one is actually holding the reference as previous. You have this two, which is actually as current, and we have this three, which is actually holding the reference as next, and three is pointing null, right? We'll do the same things again. Current will point to previous, right? And then previous would be updated as current, and this current would be updated as next, right? And we'll keep on doing it so on and so forth until we reach our last node of the value. So what would be our next iteration? So 2 is pointing to 1 is pointing to null, and 2 pointer name is now previous. We have 3, we have current, and we have a null which is pointing to next, right? Now what will happen? Again, the same thing will happen. Current to previous, previous will point to here, and the next will point to current, right? So what would be our termination condition? So we will do all these things while our current is not equals to null. We will follow the steps, and at last you see the original the the original head of our reverse linked list is this 3, right? And this 3 is now having this reference pointer as previous, right? So we will return previous from here, right? Okay, although there were specific videos for reversing the list and the getting the middle of the linked list, but still, for those who are solving this question for the first time, I just spent some time in explaining both of the algorithms, right? Now, please pause this video here. You should be able to do this code by yourself. This is the previous code. Please take a screenshot and try to code this approach by yourself, right? Now, let's get to the coding section again. So we will expand the view, and we're gonna start the code. So let me delete all these things. So first step is to get the middle, then reverse the second half. Reverse the second half, right? And compare the two lists. That is first and second half, right? And we'll have a node reverse function as well. So let's complete the node reverse function very quickly. So node reverse, node head, and we're gonna make some pointers. That is node current is equals to head, and we have previous equals to null. We have next is equals to null, right? Now what we see in the pseudocode that we will go till while current not equals to null, right? And there was a 4-step thing. So we will first appoint our next pointer, that is current is equals to current dot next. Then we will point our current to previous, and we will shift the pointers for the next iteration, right? So my previous would be current, and current would be next. This is the shifting of the pointers for the next iteration. Okay, so now we will get the middle. So we're gonna maintain some more pointers, that is node slow is equals to head, and fast is equals to head. Now we already discussed the case that why we are writing while fast not equals to null and fast dot next dot next not equals to null. This was the case we were handling for both of the cases. That is, it can be the list can be of odd length and the list can be of even length, right? So that is the case. We'll move our pointer that is slow by just one pointer ahead. That is slow is equals to slow dot next, and this would be fast is equals to fast dot next, right? We also saw that there would be our first half of the list, right? We need to separate our first half. Separate in the sense your first half last node should be pointing to null, right? In that case, and this flow will definitely give you the middle of the linked list. So we need to maintain the pre-ptr, let's say the previous pointer of your slow, right? So that is why I need a new pointer that is pre-ptr slow, again pointing to null. And before updating our slow, we will update our pre-ptr slow as well, so that it stays one step back to our slow pointer, right? So now we have the middle node of the linked list, so that becomes the second half. Let's separate the first half. So I will just say pre-ptr slow dot next is equals to null. Here goes our separation of the first half of the linked list. Now we need to reverse the second half, so I will store it in the, let's say, a second head. Second head is nothing but reverse of what is the middle name is slow, right? Now we need to compare both of the lists. So when we are comparing both of the list, right, or let's say checking for the palindrome, right? So both list, or let's say the nodes present in both of the list, respective in both of the list, should have some values, right? So I need to write a while condition where both list exist first of all, right? So the first list head pointer is stored in head, and the second list pointer, the head is stored in second head. So I'll just say while head not equals to null and second head is not equals to null. So while both list exist, we're gonna compare the values, right? Now at any point of time, if I get that my head dot data is not equals to second head dot data, then in that case I would say that this is not a palindrome, and I will just say return false, right? And if that's not the case for one of the nodes, then we need to iterate for rest of the nodes as well. So I would just say that my head is equals to head dot next, and similarly second head is equals to second head dot next, right? And if this condition never matches for any set of nodes, then I will just say that my entire linked list is a palindrome. Now if you see here, we did not use any space, any extra space, except some few pointers, and that few pointers can be considered space as a constant, right? So yeah, I think this will work. So we separated the first half of the list, we reversed the second half, we stored the head of the second half in the second head, and now we compare the two lists side by side with all the respective nodes. At any point of time, we get a mismatch, we return false, else we keep on iterating and return true. Yep, this should work. This should definitely work. Let us compile and run. Meanwhile, it is compiling and running. Let us again discuss the time and space. So time is O of n, right? This reverse is taking O of n, and similarly, this is also O of n, and this is also O of n. O of 3n, you can say, but ignoring the constants, O of n. So you're missing a return statement. How is that possible? Let me see. Where are we missing that return statement? Okay, so in this reversal, we did not return the new head, which is stored in previous. Let's compile and run again. Great. Now we will hit the submit button for this code, and we shall end this video once we have a successful submission. Great. तो कहीं तो हमारा null pointer exception हुआ है. मेरे को एक बार check करने दो code. Okay, we did one mistake here. So line number 84 is giving us. So we discussed this correct. We discussed this correctly in our pseudocode, but there was a typo. Like we mentioned 2 times next, but we should only maintain fast.next not equals to null. Great. So our expected and their output matches. Let us now hit the submit button for this code. ठीक है यार, तो एक और टेस्ट केस जिसे मैं हैंडल करना है. देखो यही होता है, लाइव कोडिंग करने से ही होता है, नहीं तो मैं तो कोड वर्क थ्रू देकर निकल जाता हूँ. तो ठीक है, इस केस को हमें और हैंडल करना होगा कि एक लास्ट केस है, आई थिंक, इफ देयर इज ओनली वन नोड, राइट? So if head is equals to null, then in that case, I would just say head dot next is equals to null. Then that means there is only a single character, or let's say a single node. And a single node or a single character is always considered to be a palindrome. So let me write a comment as well. Have single node. Now I will just hit the submit button. I'm confident on my code. So great, yeah. The code has been successfully submitted. So we actually did a great thing in this question. We handled the specific cases and we went from method 1, that was the space, that was time as O of n, and space as O of n using the auxiliary stack space. But in method 2, all the things were iterative, no recursive stack space involved, else, or we did not use any other space as well. So it would be O of n and O of 1, right? So I think that's it for this video. Few last things. If you have liked this video, if you have got help from this video in any slightest manner, तो जरूर से subscribe कर देना यार. Do like, share and subscribe. And this is our DSA repository. This was our yesterday's question of the POTD streak. So this repository consists of more than 500 questions, precisely 537 maybe. You can use this repository, start and fork this repository for practicing your DSA problems and can help in the interviews as well. And what else? What else? So today's day, hmm, today's day marked as in this 21 days of challenge, today's day would be 15. Today's day would be 15. We are very close on completing this 21-day challenge. Hope you are also solving. And in our global streak, this day would be 537, I guess, right? So let us continue this streak. Till then, keep learning, keep growing. Bye bye, and take care, guys.